So in this lesson we're going to talk about matter, the states of matter, the changes of matter, definitions of matter, and we're also going to get into how matter changes. So we'll do physical and chemical properties and changes. Okay, properties and changes. And we'll stop there and then we'll head on into the atom and things like that in our next lesson. So you'll notice on the front of your notes packet this time I have the standards listed that are connected with what we're learning. And I would like for you to just pause this and take a few minutes to skim through that. You'll notice this covers a lot. We are not going to cover every disciplinary core idea and every facet of the standards in this unit, but we're going to set ourselves up so that we can fully explore these later. We're going to make sure that we're focusing on states of matter and state changes, physical and chemical properties and changes. We're going to talk about the attractive and repulsive forces, especially those associated with the atom and the nucleus. That's really what we're going to get into. We're going to talk about conductivity, and as I said, you're going to make your own battery, hopefully, to charge a cell phone in the case of a zombie apocalypse scenario. And we're also going to talk about motions of particles. Again, we're going to be talking about those motions associated with the different states of matter and their changes. Our first section is matter and its properties. You know most of this, but it's good for us to review, and it's good for you to write the definitions and the important words out so you can become experts in this area. Chemistry is the study of the composition, structure, and properties of matter and the changes it undergoes. That's very important. A lot of chemistry is the study of change, including energy changes that accompany those. A chemical is any substance that has a definite composition. We talked about this on a bell ringer, but all matter, living and non-living, natural and artificial, has a chemical basis. It's a common misconception that any chemical is artificial or unnatural and therefore bad. And so just remember, all natural things and many of the things, or all of the things that we think of as good and healthy, are also made of chemicals. So matter is anything that has mass and occupies space. It has mass and occupies space. Energy is the ability to do work to accomplish some change. I don't really like that definition. I'm going to have to find another one that I like better, but that came straight out of my AP textbook there. Ability to do work, and that's also what's on your test, to accomplish some change. Okay, now there are three main states of matter. You should know these. They are your solids, liquids, and gases. Solids consist of particles that are close together, and they have a regular, close together and have a regular and predictable pattern of particle arrangement. Pattern of particle arrangement. This is known as a crystalline arrangement. A solid has both fixed volume and shape. Solids have very strong attractive forces and are fixed in position compared to liquids and gases as well. A liquid consists of particles closer together than in a gas and has a definite volume but no definite shape. Has a definite volume but no definite shape. And here's my shortcut for doing no in notes. It really does actually save a little bit of time, is to just do the O, like the no smoking thing. So definite volume, no definite shape. It will expand, it takes the shape of its container. It takes the shape of its container. Liquid molecules can flow around each other. And then gases consist of particles that are widely separated. Widely separated and has no definite shape. Widely separated, no definite shape. It will expand to fill any container. And here's a little note. Gases are still considered fluid, as they do have the ability to flow, even if you can't see them. So here we have 3 pictures of the solids, liquids, and gases. Here's our solids. Notice they're in a definite structure, a definite arrangement. That's a crystalline solid. Okay, and then we have a liquid. And then we have the gas. Notice how far apart the gas molecules are. They're all moving very fast, bouncing off one another. The liquid version of the water molecule, they're still close, but they're able to flow around one another. And then the solid of the water molecule, notice they're actually a little bit more spread out in this arrangement, but they are in a definite structured arrangement, whereas these are still moving and flowing around. So if you think about it, ice, you can't really see, anything moving around. It's not flowing. And liquid water, you can see definitely is flowing. And then gas, vapors, and you will see moving as well. So an important fourth state we're just going to mention is known as plasma. It's a high temperature physical state of matter in which atoms lose most of their electrons, particles, the electrons, or the particles that make up atoms. It is found in fluorescent light bulbs and stars. So we're really just going to mention that here and focus on the main 3, solid, liquid, and gas. So all matter can have chemical and physical properties. A chemical property relates to a substance's ability to undergo changes that transform it into different substances, totally different. So when a chemical reaction happens, for example, between baking soda and vinegar, the substances after the chemical change are no longer baking soda and vinegar. They're sodium acetate and they're carbon dioxide gas. And so whereas vinegar is safe to eat, you really wouldn't want to eat sodium acetate. They're different. Physical properties are next, and they can be observed or measured without changing the identity of the substance. So without changing the identity. These are things like melting, boiling, freezing. That word is identity. That's an N. Identity. Melting point, boiling point, which is not the same as catching something on fire. Now that's a chemical change. And freezing point. And you'll see all the state changes right below here. So a change of state is a physical change of a substance. So if you're just talking about a state change, you're still just talking a physical state. Because, for example, when you melt chocolate, it's still chocolate. You melt water, it's still water. Or you melt ice, it's still water. Something boils, it is still the same chemical. And so here are your change of state, process names, and examples. It looks a little messed up on my screen. I believe on your notes, this is going to be your blank area that's going to have the process name. So something happened when I imported this in. So I'll just probably write your process names out to the side here. Just so I'll have some more room. So if you're going from a solid to a liquid, like ice to water, that's called melting. If you're going from a solid to a gas, like dry ice to CO2 gas, that's sublimation. If you're going from a liquid to a solid, such as water to ice, that's freezing. A liquid to a gas is vaporization. Vaporization. A gas to a liquid, like water vapor back to water, is condensation. And then a gas going directly to a solid is called deposition. You'll notice in the visual right here that you're generally going from a gas to a liquid to a solid and so on. But if you skip a step, then it's going to be one of these guys right here. Okay, that's kind of a shortcut where you go from a solid directly to a gas or a gas directly to a solid without stopping at the liquid, because we're used to a solid melting into a liquid, and if it continues on evaporating and then coming back from a gas, it condenses back to a liquid and then freezes to a solid. We're not really used to these two where it totally skips the liquid, but I just want you to make sure that you get those in your vocabulary as well, so you'll understand if one of those happens, it completely skips that liquid state change. So we have a few physical properties that we deal with a lot. The first one is density. It equals mass over volume, or D equals little m over little v. You'll need to definitely have this memorized. That way you can manipulate it. So if you have D equals m over v, you have the density, and you have the mass, you can figure out the volume, and so on. Just by using algebra, you could go on and say, well, okay, I need to solve for v. This is what I want. So you can just algebraically solve that. So you'll multiply both sides by v. Whoops. Just like in algebra. So that'll get rid of the v on this side. It'll leave you with volume times density equals mass, and of course you want to get volume all alone, so now you'll have to divide by D to get the density. Boom. So you end up with V equals M over D. You really need to know how to do this with any formula if you're going to do anything at all in the sciences, regardless of whether it's biology, chemistry, ag econ, pretty much physics, any of those things. You're going to need to know how to take one formula that you memorize, such as this one, and as long as you'll memorize the basic one, then you can derive, that's what it's called, derive formulas. Okay, that is a very important skill, and I'll put this on your quiz after these notes because you'll really need to know how to do that. So ask me if you have any questions about that. And then very quickly here, the last couple of ones that we deal with a lot is mass, which is a measure of the amount of matter. Again, a physical property. It's usually measured using a balance or scale. please note that mass and weight are not the same. Okay, weight is a measure of the gravitational pull on matter. So weight's going to change. Like if you're on the moon, your weight is not going to be the same. Okay, if you, not the same. Okay, not. If you are on the moon, though, your mass is going to be the same as it is on Earth. Both of these are compared to Earth. So just know weight has gravity considered, whereas mass is just determined by using standard masses that our balances and scales are calibrated with. So you want to try to get used to saying what is the mass of, say, that baking soda instead of what is the weight. You want to get used to saying the word mass because that's really what we're talking about. And our last physical property that we talk about a lot is, of course, volume, which is the amount of space occupied by an object. Amount of space occupied by an object. The last two things we need to talk about, and then we are done, are chemical changes and physical changes. And we've been talking about that some, at least if this is the year 2015. I'm not sure if I'll do this the same next year, but if we haven't, we will be. And so chemical changes are one or more substances are converted into different substances. I'm going to write that out here. Into different substances. I already touched on this when we talked about chemical properties. Okay, different substances. Examples are rusting iron, metal corrosion because of acid rain. These are things that really you cannot easily reverse, if you can reverse them at all. They will take some sort of chemical manipulation. And here are some pictures here. We have looked for indicators of change. Okay, indicators that it's chemical. And here are some of them listed in this picture here. So we've got bubbling and fizzing here. So fizzing, bubbling, that's going to be one thing you can look for. We've got two clear liquids. This one's clear, this one's clear. They come together and make a yellow. Probably a precipitate, but it's definitely a color change. So we can look for color change. We can look for energy that's being released as heat and light. Okay, so that's heat, light. Also cool if there's any temperature change at all. Any temperature change. They didn't mention that. And then again we've got a color change over here with phenolphthalein, which is used to indicate whether something's acidic or basic. And then a physical change is a change in substance that does not change the identity of the substance. It does not change the identity. And again, we've already touched on this earlier. Some examples are grinding, cutting, melting, boiling. It's still going to be what it is even after it is melted. Just a little note right here. The boundaries between physical and chemical changes aren't always clear. Okay, there are disagreements between scientists. For example, some chemists would consider dissolving sucrose, which is sugar, into water to be a physical change, whereas many would consider dissolving table salt in water as a chemical change. And this is going to be because we're talking about a molecule versus an ion, and they consider the dissolving of something that's ionic and the dissociation as something chemical, whereas just a molecule they do not. And we can touch on that later, but I just wanted to point that out, that it is not always a definite physical or chemical property or change.